Have you ever wondered what makes your phone's processor different from the one in your high-powered gaming PC? They both run apps, browse the web, and play games, but underneath the hood, they follow two very different design philosophies: RISC and CISC. Understanding this difference is key to understanding modern computing. So what are they? RISC stands for Reduced Instruction Set Computer, and CISC stands for Complex Instruction Set Computer. The names themselves give you a huge clue about what they do. Let's break it down. Imagine you're building a piece of furniture. A CISC processor is like having a super advanced, multi-purpose power tool. It can drill, saw, sand, and even screw in bolts, all with a single, complex command. You press one button, and it performs a whole series of actions. In computing terms, a CISC processor can execute a complex task, like multiply two numbers from memory and store the result back in memory, with just one instruction. The goal of CISC was to make the programmer's job easier by packing as much functionality as possible into each instruction. The processor does the heavy lifting, translating that one command into a series of smaller micro-operations internally. This was great in the early days of computing when memory was slow and expensive. You could write shorter, more compact programs. Now let's think about RISC. Instead of that one magical multi-tool, a RISC processor is like having a set of simple, high-quality, individual tools. You have a drill, a saw, a screwdriver, and a sander. Each tool does one thing, and it does it incredibly well and incredibly fast. If you want to build that same piece of furniture, you have to use each tool in sequence. You'll drill the holes, then saw the wood, then sand the edges, and finally screw it all together. It's more steps for you, the builder, but each step is lightning fast and efficient. This is exactly how a RISC processor works. It has a small, highly optimized set of simple instructions. Things like load a value from memory, add two numbers, or store a value to memory. Each instruction is designed to be simple enough to execute in a single clock cycle. So, a complex task that took one instruction on a CISC machine might take 4 or 5 instructions on a RISC machine. This sounds less efficient, right? But here's the magic of RISC. Because each instruction is so simple, the processor hardware itself can be much simpler, smaller, and more power efficient. And since each instruction executes so quickly, you can often complete the entire sequence of simple instructions faster than the single complex instruction on a CISC processor. Let's dive deeper into the key differences. First, the instruction set. As we said, CISC has a large set of instructions, some of which are very complex and may not be used very often. RISC has a small, uniform set of instructions. Think quality over quantity. Second, execution time. CISC instructions can take multiple clock cycles to complete because they're doing so much. RISC instructions aim for a single clock cycle. This makes performance much more predictable and easier to optimize through a technique called pipelining, where the processor can start working on the next instruction before the current one is completely finished, like an assembly line. Third, memory access. CISC instructions often directly manipulate memory. For example, add this number in memory to that number in memory. RISC processors typically follow a load-store architecture. This means you have to explicitly load data from memory into registers, which are small, super-fast storage areas on the chip, perform the operation, and then explicitly store the result back into memory. This might seem like more work, but it simplifies the processor design and speeds things up because operations on registers are much faster than operations on main memory. And finally, complexity. The complexity in CISC is in the hardware. The chip is more complex to handle the intricate instructions. In RISC, the complexity is shifted to the software, or more specifically, the compiler. The compiler is the program that translates human-readable code into machine instructions. For RISC, the compiler has to be smart enough to break down complex tasks into the optimal sequence of simple instructions. So, where do we see these in the real world? This is where it gets really interesting. The most famous examples of CISC are the Intel x86 and AMD processors that power the vast majority of desktop and laptop computers. If you're using a Windows PC or a Mac, you're almost certainly using a CISC-based processor. They've been dominant in this space for decades, building up a huge ecosystem of compatible software. On the other hand, RISC is everywhere else. The ARM architecture, a prime example of RISC, is in over 95% of smartphones and tablets. Your iPhone, your Android phone, your Nintendo Switch, they all run on ARM-based RISC processors. Why? Because RISC simplicity leads to lower power consumption, which is absolutely critical for battery-powered devices. Other RISC examples include MIPS, which you might find in routers and other networking equipment, and the new, open-source architecture that's getting a lot of attention, RISC-V. Now, you might be thinking, okay, but my Intel processor is super fast, and my phone is also super fast. So which one is actually better? The truth is, the line has blurred over the years. Modern CISC processors from Intel and AMD don't actually execute those complex instructions directly anymore. Internally, they break them down into simpler, RISC-like micro-operations which are then executed on a high-performance, pipelined core. So, in a way, modern CISC processors have a RISC engine inside. They maintain backward compatibility with the complex x86 instruction set for software, while getting many of the performance benefits of a RISC design. At the same time, RISC processors aren't standing still. The latest ARM chips found in Apple's M-series MacBooks, for instance, are delivering performance that rivals and even beats high-end CISC processors, all while maintaining incredible power efficiency. This shows that the RISC philosophy of simplicity and efficiency is incredibly powerful. So why should you care about any of this? Because this fundamental design choice between RISC and CISC affects everything about the devices you use every day. It influences performance, battery life, cost, and the type of applications a device is best suited for. The dominance of RISC in the mobile world is what enables you to have a powerful computer in your pocket that lasts all day. The continued strength of CISC in the desktop market is thanks to decades of software compatibility and its raw, high-end performance capabilities. The battle between these two philosophies has driven innovation in the processor industry for over 40 years. It's a fascinating story of trade-offs: simplicity versus complexity, hardware versus software, power efficiency versus raw performance. And with the rise of new architectures like RISC-V, the story is far from over. The choices made by engineers designing these tiny, powerful brains will continue to shape our digital world in ways we can only begin to imagine. Next time you pick up your phone or sit down at your computer, take a moment to appreciate the incredible engineering inside. Whether it's the complex, all-in-one approach of CISC or the simple, elegant efficiency of RISC, you're holding a masterpiece of technological design. Thanks for watching. If you found this explanation helpful, give this video a like and consider subscribing for more deep dives into the technology that shapes our world. Let me know in the comments which architecture you think will dominate the future. See you in the next one.